Hi, all. We are in a crunch time now. We only have 3 weeks left, so I thought I would help out a little bit with the homework. Um, this is module three, lesson one, and let's just look at a few of these. Let's start with number 5. All right, you randomly select an integer from 0 to 39, and then randomly select an integer from 0 to 4 inclusively. What's the probability of selecting a 3 both times? All right. So basically, this is really a multiplication rule problem, but I'm just going to show you how to do this. All right. So you've got to choose an integer twice, and the first time you have a possibility of 40, and the second time you have a possibility of 5 different numbers. So this is 0 to 39, and this is 0 to 4, okay? So the fundamental counting principle says how many different ways can I pick numbers here? So you just multiply 40 times 5, and that ends up being 200. Okay, and then basically there's only one option here that this number is a 3. It says in the problem there over here, what's the probability of selecting a 3 both times? So you have basically 1 out of 40 here and 1 out of 5 here. All right, so that comes out to be 1 over 200. Right, so the answer there is 0.005. All right, don't worry too much about that one. Just know how to do it. It's using the fundamental counting principle, and I hope that helps you out there. This next one says 18 of 200 digital video recorders in an inventory are defective. 18. So defective. There are 18 out of 200. All right. What's the probability that you randomly select a DVR that is not defective? Right, so the probability of defective is going to be 18 over 200, and that comes out to be 0.09. All right, and then the probability of not defective is equal to the complement, which is 1 minus the probability of it being defective, which is 1 minus 0.09, which is 0.91. Okay, so that's how you get the answer there. Okay, let's go on to problem 12. All right, so this one is also the fundamental counting principle. A realtor uses a lockbox to store the keys to a house that is for sale. The access code for the lockbox consists of 4 digits. All right, so basically, you have 4 digits here. The first digit cannot be 5, and the last digit must be odd. How many different codes are available? All right, note that 0 is considered an even number. Okay, so you've got 4 digits, and there's basically 0 to 9, so there's 10 possibilities for each of these digits, except it says the first digit cannot be 5. All right, so 5 is left out, so that just leaves us, there's 10 numbers here. So, but since 5 is left out, we only have 9 options, right, for the first digit. And the last digit must be odd, right? The last digit must be odd. So, how many odd numbers are there from 0 to 9? There's going to be 5, right? So 1, 3, 5, 7, and 9. All right, there's 5 possibilities here. And then these two numbers can be 0 to 9, right? So 10 possibilities. And if you multiply all those together, let's see here. You don't have to, this is kind of a strange calculator, but 4,500. Okay, just multiply all those out. All right, fundamental counting principle. Let's look at number 14. Find the probability. A probability experiment consists of rolling a six-sided die, numbered 1 to 6. Find the probability of the event below. All right, so this is classical probability. The sample space, all right, this is the total possible outcomes, and that's going to go in to the denominator, right? For classical probability, you put the total number of possible outcomes in the denominator. We have 1, 2, 3, 4, 5, 6, all right? And what's the event? A probability experiment consists of rolling. Find the probability of the event rolling a number less than 4. So the event is less than 4. Let's see here. Less than 4. All right, so what is that? That's going to be 1, 2, or 3. All right, so there's 1, 2, there's 3 possibilities there. It's just these 3, 1, 2, 3. And so the probability is just going to be 0.5. Okay. All right, let's do one more. Let's do this number 16. All right, so it says there's a frequency distribution, right? So that means that the number of counts is going to be displayed. The number of voting age citizens in a certain country by age. To find the probability of voting age citizen chosen at random is in the age from 45 to 64. Let's click on that. All right, so it looks like there's 48.5 million in this age group, and there's 55.9 million in that age group, and we want to find, which one do we want to find? 45 to 64. So, you know, what's the probability if we pick a random person that they're going to fall into this group? Okay, so the way we do that is we add up all the total here. So let's see, let me do that real quick. 48.5, 55.9, 75.1, 44.1. All right, so the total, let's see if you can see that there. The total is going to be 223.6 million. Okay, that's the total. All right, so the probability of this event, of picking in this age group here, 45 to 64, is going to be 75.1 all over the total, 223.6. All right, so that comes out to be 75.1, 223.6 divided by is I got 0.3359. I don't know what we have to round that to. Let's see what it says here. All right, this says 3 digits, round to 3 decimals. All right, so this is 0.336. All right, so basically, look at these two types of problems here. This one is classical probability, where you put the total number of possible outcomes in the bottom, and then the total number of outcomes in the event. In this case, the event was less than 4, right? If it said less than 3, then I would only have 1 and 2, like 1, 2 possibilities, and it would be 2 over 6, right? The second one uses this, and this is, you know, more empirical, where you just count the number of people in these age groups, and after you do that empirically, just add the total, and then you can calculate the probability that you picked someone in one of these age groups. So you add those up. When you have a chart, the denominator is going to be the sum of all of these outcomes. Okay, so the sum in this case was 223.6, and then the numerator is going to be the event, the frequency of the event that you're looking for. In this case, 45 to 64. Okay, so anyway. hopefully that'll help you out on the first section. If I get a chance, I'll look at some of the other ones for Module 3, Lesson 2 and 3. You don't have much time left in this course, so get started on that. If you have a problem with something, let me know, which problem you're talking about, and we can work through it. Thanks.